Guys, a little theory before we move forward. So, some very important point about round robin, and let's see what this means. If the time quantum is less, then the less is less, then the number of context switching will be more, and the response time will be less. Now, what do I mean by this? Now, the time quantum is less, so your process will be executing for less unit of time, and more context switch will be there. That is, if the process there are two process P1, P2, P3, P4, and it is executing for 1 unit of time, then the next chance is given to the next arrival process. Suppose it is P2, it is executing for 1 unit of time, so it has been executed at first unit of time, it has been executed for second unit of time, it then again P3 execute for 1 unit time, it has been executed at 3 unit of time, then again P4 1 unit time, 4 unit, then it is executed at the fourth unit of time, so your response time will be less. The process start executing at the lesser unit of time, so response time decreases but your context switches increases. Now what do I mean by context switch? Because process is not getting completed, it is getting preempted earlier only, so your context switching will be more if the time quantum is less. So you have to just select an optimal quantum, not a very large. Also, why not very large? Because if the time quantum is greater than the burst time of all the process, then it behaves similar to FCFS, right? We don't want that. FCFS is not very great algo, so let's not make the time quantum greater than burst time of all. So you need a optimal time quantum. What is context switch? I already told you that saving the context of one process and loading the context of another process. What do I mean by context? Your process attributes, I already told you, your attributes of the process is known as context. Saving the context means saving the process attributes, so that means that is what I mean by context switch. Saving the context of one process, that is getting preemptive, and loading the context of another process, that is getting started, it is known as context switch, right? So you don't want very much context switch. Now one more last thing, if there is one process P1 and only one process in the system P1, and it requires 6 units of time, 6 unit of time, and the time quantum is 2 unit, so you will be executing it for 2 unit, getting making a preempt, and then again loading it, executing it for 2 unit of time. So context switch will be there even if there is one process. Remember, again I am repeating, context switch will be there even if there is one process. Remember, just remember this. Let's see one question here. This is also probably a gate question. Consider a system which has four processes P1, P2, P4. All of them are arriving in the ready queue in the same order at time 0. Burst time requirement is this. Then what is the completion time of process P1 assuming round robin time quantum of 1 unit? So your working remains the same. Make the ready queue, and below it make the Gantt chart. Your analysis should be correct always, then only there's some chance for you to get the right answer, right? Let's make the Gantt chart. At now, which process to execute at time 0? At 0 all the processes are arriving, so the process which will choose is based on the process number, so P1 will be chosen, right? P1 choosing executed for 1 unit of time 1, burst time becomes 3. Now execute P2, all are in the ready queue, right? P1, P2, P3, P4, because all are there at time 0. P1 has been executed for 1 unit of time. Does it require more? Yes. So write P1 again here. Now execute P2. P2 require 1 unit of time. Yes, it's done. So don't write here P2 again. Now P3. P3 requires how much? P3 require 8. But time quantum is 1. So execute for 1 unit of time. It becomes 7. Now next P3 require more, right? Now P4 require 1 of time, can we execute for 1? Yes, time quantum is 1, so write 4 here. P1 execute, P1 how much time quantum it required? It required 3, so can we execute for 3? No, only 1, so write 2 here and write 5 here. P1 require more. Now P3 execute for 1 unit of time, make it 6 again, and write P3 again here. Now P1 execute for 1 unit of time and require more. Yes, so write P1 here. Have we cancelled it here? I guess not. Now P3 execute for 1 unit of time, it becomes 5 here. and it require more. Now P1, is it completed now? At last it has been completed at 9 unit of time, and the question is asking till when P1 is getting completed. It is getting completed at 9th unit of time. So your answer is, let's write it in another color. Answer is 9. We have found it. So analysis should be correct, then only there's some scope for you to find the answer. And if you found it amazing, like and subscribe. Okay, thank you.